Okay, let's look at examples using the empty set. The empty set seems to be pretty confusing. Even if we understand situations or operations using regular sets, often we'll have a harder time doing the same thing using the empty set. So first, let's remind ourselves of two definitions. We want to look at the difference between an element and a subset. Okay, so we're going to say if X is an element of S, what does this actually mean? It means that S is a set and X is an element of S. Or we could also say S contains X. Okay, now if X is a subset of S, what does this mean? This means S is a set and X is a set and every element of X is also an element of S. Or put another way, everything contained in X is also contained in S. Okay, so these definitions are going to be helpful as we ask some questions involving the empty set. Okay, so again, what is the empty set? It's the set with no elements in it. So we can write it this way, or we can also write it this way. These are the same thing, different notation. Okay, so we're going to ask a couple questions. The first question we're going to ask is whether it's the case that the empty set is an element of the empty set. Okay, well, what elements are contained in the empty set? No elements. There are no elements in the empty set. So, this part, that something is an element of the empty set, cannot be true. So this is false. Okay, how about if the empty set is a subset of the empty set? Okay, so let's remind ourselves what subset means. It means that every element in the subset is also in the set. Well, there are no elements in the empty set, and these no elements are also all in the empty set, right? So it's trivially true, but it's still true. Every element that's in the empty set, i.e. none, is also in the empty set. Okay, so this is true. All right. Let's also ask, how about if the empty set is an element of the set containing the empty set? Okay, well, let's look at this set. It's a set, and it's containing the empty set. So its element is the empty set. That's exactly what we were asking. Is the empty set an element in this set? So yes. So this is true. Okay, let's also ask if the empty set is a subset of the set containing the empty set. Okay, this one, we can actually remember that the empty set is a subset of any set. It doesn't matter what set it is. Okay, so for example, if we're asking whether the empty set is a subset of this infinite set, remember how we build subsets? We get to decide for each element in the set whether or not it's going to be in the subset. And one of the possible subsets is saying no for every element. So in that case, when we say no for every element, we end up with no elements, and that's a subset, and that subset happens to be the empty set. So this is true, and this is also true. So yes.